Okay, moving on to our next panel. Just before we move, I would like everybody to one more shout out. Is everybody here? Yes. Good job.
So we'd like to start with our next panel. We live in a connected world where everyday devices have smart sensors with the ability to not only collect and process information, but also collaborate with other devices. The notion of Internet of Things was introduced by Kevin Ashton in 1999.
Was everybody knowing this, that it has been introduced by Kevin Ashton? No? Okay. Something, we did something to increase your knowledge today.
Yeah.
At least one Google search, right?
Yeah.
Okay.
So the Internet of Things is the idea of connecting physical objects to the Internet. It carries the possibilities offered by a world where everything is tagged and connected to Internet.
So in our second panel discussion, we have our speakers from Redpine Signals, Aeris Communications, Arrayent, and GigaOM, if I'm spelling it correctly. Is that correct? Okay. To explore the numerous possibilities this trend has opened for the world. And I take this opportunity to introduce the moderator of our second panel discussion. He typically consults on topics such as semantic web, search, and consumer e-commerce experiences, which are flying on my head right now. He also founded Brilliant Forge to help organizations focus their consumer insights, product vision, business strategy, and technology capabilities. Prior to founding Brilliant Forge, he was a Silicon Valley product executive with over 18 years of experience designing, defining, and building consumer products. He worked at a few best known technology companies like Apple Computer, Yahoo, eBay, and IBM. I would welcome Larry Cornett here. He's already on the stage. Larry, if you can wave to the people so that people can see you. I already made that announcement when we started this conference that I'm not from the IT background, so Internet of Things is totally new to me. I'm pretty sure I'm going to take, after having this discussion, some powerful information with me when I go back. Looking forward to it. Larry, it's all yours.
So thank you for having me here. As I kind of pointed out, I'm a consumer guy. I've spent some time in enterprise, but I'm primarily focused on consumer products, and so it's really exciting for me to take a look at this, the Internet of Things, from the perspective of a consumer lens of what does this do for people, the average person, and why would they be interested in it. But let me introduce the panel that we have here today. First, I have Venkat Mattela. He's the founder and CEO of Redpine Signals. It's a wireless semiconductor and systems solutions company. It's headquartered here in San Jose. Venkat has over 30 years of engineering and management experience in the semiconductor industry, and he drives the company's R&D and engineering, in addition to managing the business. Next, Subbu Balakrishnan. He's the head of analytics and billing at Aeris Communications, and he focuses on the M2M platform, machine-to-machine communication. It is the only cellular network designed and built exclusively for machines. He's also one of the organizers for the IoT Silicon Valley meetup. And then finally, let me introduce Raghu Tarra. He's the VP of Engineering and Operations at Arrayent. The Arrayent Connect platform is a cloud and embedded platform for connected products that enables manufacturers, retailers, and service providers to connect consumer products to web and smartphone applications. Raghu has 20 years of industry experience, has been involved in solving complex engineering problems, building distributed systems for various applications domains, including working on the notable Slingbox. So welcome. So I'm just going to have a couple of slides to kind of set the context for the Internet of Things before we dive into some discussion with it. So this is the first thing. It's an eye test. Can you read that? All right. So essentially, what this is just kind of setting the context for what do we mean by the Internet of Things. And the interesting thing and the somewhat frightening thing when you think about the enormity of what this is going to mean for us and what we have to manage is it's pretty much everything. This ranges from smart desks, which are sensors that have a camera and a device that's smaller than a grain of rice and can be distributed anywhere, all the way up to industrial applications with ships and trains, bulldozers, and even your Tesla is really a connected device to the internet. And so the opportunity really is to look at all of this data all these devices communicating with each other, and decide, well, what do we do with that is more meaningful than you just having a one-on-one kind of conversation with your one device. Things are changing, and now it's going to be devices talking to devices. By 2020, we're expecting there to be 50 billion connected devices available. 50 billion. What's that going to do to your network? So that's going to be interesting. And then GE, who's actually one of the largest players in this space, I mean, they do everything from your coffee maker in your kitchen all the way up to jet engines. They're looking at the opportunity from Internet of Things, basically boosting GDP globally anywhere from 10 to $15 trillion, by 2030. And when you start to look at the applications, and just one example, when you start to have devices that are aware of imminent failure. Trains are a great example. You can look at train tracks, you can look at the wheels on the trains, and being able to actually determine predictive fault, look at predictive fault analysis and say, it's time to actually repair that before it fails, before you have a derailment that could cost you up to $10 million. And so when you multiply that by all the different industry sectors and look at the savings of having these connected devices, you start to see how it could become trillions and trillions of dollars. So this is from Beecham. It's a little hard to read, a little overwhelming, but it does show you kind of the enormity and the scope of everything that falls within this space. So you're looking at all the different sectors, and I mentioned a few of those, but you look at the connected home, you look at wearables, you look at healthcare, public sector, retail, and then start to layer in the different types of applications and experiences you can have with that. And then looking at the opportunity for those to be woven together to do things that are much more than just that individual experience. So it is much larger than the sum of its parts. And then I just created kind of a simplified version of what this stack starts to look like. But you have this entire range of connected devices. As I said, it goes all the way from smart dust up to a bulldozer. I mean, it could be anything that is connected to a network, communicating, sharing data, and connecting to other machines. Then on top of that, you have the opportunities that we've had with cloud computing and big data, which means that now these connected devices don't have to have all the computing horsepower and storage on the device itself. That's why it's possible to have something the size of a grain of rice. So it's very interesting what becomes possible when you can count on having the cloud and that compute power to basically take your data, do something meaningful, transform it, and bring it back. And then on top of that are really these unique software platforms that I think have been starting to be created by IoT. So how do you start to have devices being able to have machine-to-machine communication? What do you do with that data, and how do you weave it together? And then there's a whole array of vertical experiences that can be put on top of this, and I haven't even captured all of it. It does all the way at the left, these little sensors and wearables. But then your typical electronics, your laptop, your phone, what's going on with your home. You look at the Nest thermostat and everything that they've been doing. And then you look at healthcare, transportation, all the way up to environmental opportunities. So there is talk about deploying billions of these sensors globally and essentially creating a global skin. Being able to detect changes, micro changes in temperature and humidity, vibration, earthquakes. Being able to do something like predict what is happening in the Philippines right now much earlier than we found out about it. And be able to save thousands of lives saying there's something coming that's much larger than we ever expected. So it becomes very exciting. And then at the top of it are these layered applications. So it's no longer single applications sitting on top of a discrete vertical. It's no longer just your Fitbit monitoring your health activity. It's communicating with everything. It's communicating with your doctor. It's being able to layer these applications on top, take access of all that data, and do something really powerful with it. So that gets really exciting for me as a consumer guy, saying, well, what could you do if you were aware of everything within my home, everything that I carry, everything that's in the office, everything within my car? What could you do with that and provide an experience that starts to take some of what we're struggling with today and remove that friction and make life a lot better for all of us? So you can start to see why this is such a huge opportunity. But surprisingly, people are kind of hesitant in dipping their toe into this. Because even though it's like 75% of global leaders when they're surveyed say, yeah, we're exploring the economic opportunities of IoT, 96% expect that their business will be using it by 2016. That's actually coming up really fast. 61% of the folks surveyed, these executives said, someone who is not exploring IoT is going to be at a huge disadvantage compared to their competitors. And yet, when you look at the majority of these companies and you ask, where are you in your cycle? Where are you in terms of deploying IoT for real within your enterprise? They all say, we're still in the planning stages. Everybody's still in the planning stages. 2016 is coming really fast. And so my first question to the panel is, well, what are the obstacles that are holding us back? What are the barriers that enterprises are facing that are keeping them from truly realizing what we think IoT could be? Who would like to take that?
I can take it.
Okay.
This is Venkat. Again, the description is very good, Larry. Thank you. So if you look at the devices that are part of the ecosystem of so-called the Internet of Things or the M2M, they're not like your mobile phones, because mobile phones are used by very smart individuals, and they can always operate it, configure things like that. Whereas if you take connecting a device, a thing, to an internet, so the device has to have a different characteristics to handle the configuration of it, a lot of the self-understanding and doing things on its own, because there's no person attached to it. So if you really look at the obstacles-wise, there is no one market segment where you can focus on. There's a 100 million or 1 billion units market is there, so that we can go ahead and spend a lot of research and figuring out how to do it. This market is inch deep, mile wide. That whatever the slide Larry showed is the key to the entire Internet of Things. That means there's no killer app, there's no one segment where we can all focus and make all the money. Because when I say inch deep, mile wide, you would have thousands of products, tens of thousands of customers, and each of them taking 10,000, 50,000, 150,000. You don't buy like 1 billion smartphones like that. So when you have this so-called the inch deep, mile wide, creating anything a quicker way. For example, we are saying 2020 we should get to 50 billion, whereas it took us 30 plus years to get to 5 billion smartphones. But in the next 10 years, you have to get to 50 billion. There's a 100x change. That means everything that we know so far in terms of doing devices, writing software, how to deploy, everything has to be different, because the change is huge. So for that, the challenge that we have is it's an inch deep, mile wide, and the time is short. So a lot of things are missing pieces. That's why people will go and deploy some 100 units someplace, other guy deploys 50 units. Both of them won't make money, because 100 units cannot support you, whatever you go through developing. So the challenge is the real market itself is different. So there has to be different methodologies in every area: device, connectivity, middleware, cloud, application. Every area, there will be a different way of thinking. So we are just trying to figure out in the device and networking side how things could be different.
So you obviously have customers who are buying products today, but I'm sure you run into this problem where you talk with somebody and they're like, well.
Absolutely, Larry. And I think one of the things that I would like to share with this group over here is many of the enterprises have actually attempted IoT or some connected device strategy, believe it or not, in the last 5 or 6 years. No one knows about it. And the reason why they don't know about it is they have attempted and failed. And they have failed multiple times. A lot of people have been fired in all of these enterprises because the way they've approached trying to get to the IoT platform has not been thought through. This is a complex problem. It's not a very simple problem. To the point what Venkat made, it requires a significant transformation of thought process within the enterprise, and it needs to be driven from the top. It requires technological capabilities within the team that have to start all the way from the device, embedded software, middleware, up to the cloud, and of course, our mobile apps and web apps. And you have to build this to scale. I have known companies or enterprises that have tried to do this, and they've gotten it right for most part. But guess what? The system supports 10,000 devices. After 10,000 devices, what? So system doesn't scale. You're talking about millions and millions of devices and sensors coming on board. And if you don't have a scalable platform, the program will fail no matter how many times you try. I think that's the significant challenge for enterprises. And only companies like LG or Samsung, who are putting in millions and millions of dollars in their R&D efforts today to do this, I think they will be out there with their solutions first. But keep in mind, they're also very closed. They're not using an open platform. For that matter, IoT does not really have any standard. It's so fragmented. That's yet another challenge in this space because it's so fragmented. Everyone wants to do it their own way, and there's no specific standard. So I think that's what we've been seeing with our customers as we bring on board more and more customers, and that's where our company is trying to help them get to a solution much more faster without going through a lot of pain.
So Subbu, how much are these lack of standards actually contributing to the problem since it's such a nascent space?
Yeah, I think one way of looking at this problem is you look at the type of companies trying to use M2M IoT. So you have the pioneer kind of companies, and then you have companies which are actually doing in development, and then you have a company which is kind of sitting on the sideline thinking about it, right? So companies which are already having it in production, like for example, the company that we have, automobile sector is one of the sector which basically has been pioneering this for some time. So the reason why, initial problem for many people were cost, actually just the radio module cost used to be high. Right. If you're buying a car which is $30,000, $40,000 car, it's easier to justify putting a radio module for $300, $400. And now the cost have come down quite a bit. But at that time, actually it's easier to justify in the domain, right? So they're able to actually, so if you look at the overall supply chain management in a connected car example, if you take a typical use case, you have a car company wants to have a connected car, it typically has to work with 5 or 6 companies. Right. Somebody who makes radio module, somebody would actually has to be putting it in a box which is compliant with the US regulations and whatnot, right? And then eventually it gets integrated, and nobody's going to pay for it yet, but somebody has to pay for the test part of it. So the way in which you manage the supply chain management for the device, and then it eventually shows up in a dealer lot. It's sitting in a lot, and somebody buys it. At the time, most of the time nowadays there are 3-year, 1-year trial period for these connected cars. During the time, the OEM pays for it. And then once it goes beyond that, how many people are actually signing up for it after the trial period? So most of the people who are in the pioneer area, they've got to the initial cost part. So now what they're struggling is actually the value for return, right? So now that I know I have all the data, what do I do with it, right? So if you're telling customer that you can unlock the car, if you look at a typical example of a connected car from a consumer point of view, example use case, you can, I have a connected car in myself, and I have an Android app. So I can use that to unlock the car. I can use that to, if forget to turn off the light, you can turn off the light. But you can use features like geofencing feature, which is actually, you can draw a random polygon and say that, if you go outside the region or go into the region, you're going to get an alert. So there are a lot of applications that's been built on top of it. But how many of them are willing to pay $20, $30 for it? And that part actually is a big aspect, because the churn is getting higher. In the automobile space, what we are seeing typically is how do you retain the customer, right? So that is where actually, if you start thinking about how to monetize the data, it's going to be a challenge. The big data comes into picture. So take an example of how somebody can monetize that. Cars actually have traction control information as part of the sensors in the tires. So you can actually use that to say whether a tire has been rotated as part of oil change. So now you can actually, as part of hyper-personalization, you can actually say, you change oil with somebody who's supposed to rotate the tire. You don't know whether they rotate the tire. Actually, that can tell you they rotate the tire. So it actually rates the oil changers based on that. Yeah. So it really matter of imagination of how you use the data. I think that data science part, leveraging that for pioneers is difficult, right? And then if you look at the kind of companies which are trying to get into it for the first time, the biggest issue is basically the cost. And companies which are doing development, the problem is actually a lack of standard is one thing, and the ability to actually leverage the vertical common feature. You take ability to unlock a car versus unlock a secured connected home. High percentage of the application logic can be shared. But there are silos in development, so the development cost is high. Right? So these are some of the challenges you're going to have in this for people who have established themselves as pioneer to people who are thinking about it.
So I'm going to ask you to put on kind of your predictive hats for a second, and looking at the high cost of entry and investment in devices and infrastructure, and it's coming down. It will come down as things get standardized. When do you think that crossover point will be where the cost of investment is low enough that the return on investment is going to be obvious enough that people can actually get into this and it'll take off? Is this 5 years, 10, 20?
Yeah, I think in my opinion, it will be around 2015, 16. because the effort of saving the cost is being done by different companies, right? So bigger telecom switch and router manufacturers. So for example, we are trying to actually come up with a single rack solution which has a cellular network core and actually has an application platform, right? In a virtualized platform where you're able to, what we call TPS, or transaction per second, how we are able to scale up and down in a cost-effective way. So as we are collaborating with more companies and we are able to actually make big players of telecom companies to come together, right? If you take a typical cellular connected world, somebody in even the current connected car world, you have 5 or 6 major vendors. The car manufacturer have to work together. As company big AT&T, Verizon of the world, they have to work with some billing companies. So billing actually is also a bigger aspect because remember the ARPUs on these, average revenue per unit on this is going to be very, very low, right? It's, typically you and me, we pay $30, $40 for our phone per month. These devices are going to be in cents, best case. So which means that all the underlying platform cannot have a huge license cost behind it or a huge hardware cost behind it. So it's really going to be a very complex problem like you mentioned. But I think in 2015-16 time where you'll start seeing that turning around.
So I'm seeing something interesting in this space, and one is that there seems to be an increasing spread between the types of devices that are being developed right now. One is that the devices, like your smartphones, are becoming increasingly powerful with more sensors, more compute power, and it essentially has a lot more power than my laptop had 5 years ago. The other is that there's this increasing specialization of these small micro devices that have very little storage and very little compute and are relying on the fact that you're connecting to it with a smartphone to manage it, or it's going to be sending data to the cloud. Where do you see the focus? Is it going to be more on these, like Teslas and smartphones and these really complex devices that can essentially absorb the cost of this because people are already paying a lot for this thing? Or is it going to be in these little Fitbits and Nest thermostats and these smaller specialized devices?
So I think the answer is if you take the 50 billion number, so obviously all the Teslas adding will be zero. So it's definitely not in the entire automotive sector, you can take it off. So what that basically means is the things that we have never thought about connecting. Okay. So the 50 billion will not come from what we already know. We know smartphones, we know cars, all those things. It won't come from there. That means it will come from a very small factor. So when you connect to a device which is like thermostat is definitely a case in that one, Fitbits and some of the locationing, tracking devices, and industrial application. If you take all those segments, the way to really address is, I think, is that the standardization is a very critical thing because when you have these 5 abstracted layers of components in the solution and there's no standard at each level, and you have this fragmented market, that's a real problem to solve. That doesn't exist anywhere. That kind of whatever you showed the sheet, right. That is a real problem. So one of the things is that every segment, that for example, if you go to the device level, what would be the connectivity technology? Mm-hmm. If you take these devices which we are talking about, these are not your smartphones where you change every 18 months. You install something, you want to keep it forever. Thermostat, you don't go and change every 18 months. And what kind of wireless connectivity technology should be there in thermostat versus a smartphone? Smartphone is something that you want to change. So that puts a lot of pressure in terms of future-proofing the connectivity technology, future-proofing the device design for intelligence collection. All those future-proofing will happen only when you have standards. If you don't have standards, you go ahead and deploy. 2 years from now, it's not secure, then you go and deploy one more time. The second one is when you try to deploy one more time, where is the value-added network? Because this is not going to come from the so-called known applications. It's going to come from your area, what consumers. Mm-hmm. That means who is going to help you to deploy? Right. So the people have to be trained in that. How will they be trained in a wireless technology which you are not even aware of? So it has to be a standards-based technology, future-proof, and the infrastructure has to be there to go and deploy in the cases where somebody wants 50 units. Today it does not exist. You have to pay a lot of money, $400K, to some company to come and do it. And I need only 50 units to track my jewelry box. So that means you need to go at every level, and the standardization has to happen. So in my view, maybe I agree with Subbu, but it's a little bit farther.
Okay.
Yeah.
Okay. So I have
one more aspect I would add to that is you look at the one more thing we have to watch out is the different government regulation patterns, right? So take Brazil, basically I think they are targeting to have all the cars connected. So it's a certain government regulation, and if you take the healthcare regulations coming along the pipeline, they require actually, for example, one of the medical device companies that we are working with, they have trying to use a connected medical device to comply with some health requirement like sleep apnea medication, a sleep apnea monitoring company that requires the data to be sent to the back-end office, to the doctor office, and that actually makes sure that the insurance company is going to get paid, it's Medicare and things like that, right? So another example is you take the connected breath analyzer, right? So if right now we look at one of the major impediment to breath analyzer is people actually have to go down somewhere, typically to a court office somewhere, to literally upload the data they've been collecting to show that they have not been drunk driving, right? So once you get a DUI, you get into that pattern where you're supposed to periodically go and upload the data to show that you're not been doing that. So if it's connected, actually more people will actually engage into that. So the state governments, some of the state governments are trying to get more of them connected. So I think the growth also is in some way influenced by how different state regulation and the country regulations are coming up.
So you've kind of raised an issue that I hear as I explain the Internet of Things to people. There's two different responses. One, people get really excited, like, oh, this is really powerful, and I can't imagine what's going to be possible. And I'm getting a very different response from folks that are a little less, I think, tech savvy, that they're like, I don't like that. I don't like the fact that there could be cameras that small. And you look at London, and I think Rio is another example of the most wired cities in the world with cameras everywhere. So what starts to come up as you start to have connected devices sharing information, medical information? What comes up, and how do we manage privacy concerns and security risks and things like that?
Well, first off, I think everyone has an opinion on this, and I agree with you that some people are concerned about how pervasive this can become. But guess what? Whether we like it or not, it's happening.
Yeah.
It's happening as we speak, and it's happening at a rate that's unbelievable. And I think I agree with what Subbu said. Personally, I feel in the next 4 years, there's going to be so much change. We'll be living in a different world. And it'll surprise us at that time. In terms of privacy concerns and security concerns, I think each of the sector will have certain rigid guidelines, healthcare being one of them. I think healthcare, you'll have much more stringent guidelines. Consumer sector, not as much, but again, it's going to be a learning process. I don't know how many of you actually read some of the recent articles about one of the, I think it was a baby cam monitor that got hacked in, right? And those are serious concerns. What's going to happen is because of those incidents, there'll be a lot of onus and responsibility being put on the manufacturers of products, the technology providers, to make sure the system is secure so that people cannot hack into it. So some of those things will become very, very stringent, and it will ultimately become a responsibility for the manufacturers of those devices to guarantee that they cannot be hacked into. As far as privacy is concerned, my personal opinion is you'll still have the same set of processes that we have today. You buy an appliance, you buy a product online, you go register. Many people don't see the fine print. By default, we are already checking a box that says, hey, anything that you know about me, you can use it. I think it's just going to be part of that. Whether this information you can control not being made public or not would still be available. But my guess is just like how we missed the fine print today, we'll miss it even in the future.
Yeah, I think that's fair. So I'm going to switch gears a little bit and talk about one of the barriers that comes up often. It's really around this connectivity. So around the wireless connectivity is like, what is it going to take to make this a reality? Because I can't even drive home without losing signal, and I live in Silicon Valley, which is kind of ironic. So it's an extremely fragmented space. It's not an entirely reliable space. So what do you think it's going to take to make this actually work so that you can set it and forget it? You know, you can put a sensor somewhere, embed it, and know that it'll be sending you reliable data for the next 10 years, and not have to keep adjusting things.
So I can take this one. So basically, if you look at the connectivity level, you might be seeing a lot of wireless technologies are already in deployment. For example, if you take a garage door opener. Somebody might be using very, very cheap wireless because everybody likes it to get for $5, $10. But right now, the volume in the so-called the IoT is very small. That means you have not really seen the real problem. If you go back 20 years ago when Wi-Fi started, there used to be a security standard called RC4. Everybody got excited. I can surf the web from my kitchen now. I don't have to go to the computer room to connect a cable. Then when the volume started going up, that was the people who were breaking into your network. Then you go to the AES, then finally end up at enterprise level security. Similar way today, everybody gets excited. My garage door I can open through my smartphone. But what if your neighbor also opens it? So right now nobody cares because you have this gadget to open the garage door. When the so-called 50 billion units happens, the whole scenario will be different. When the whole scenario is different, all those wireless technologies you hear, which I do not even know some names, they won't exist. It has to be a highly secure, IP-connected, wireless network, still sell at the cost which is almost zero. So that would be the challenge. And right now, obviously, the companies are working for the last few years in trying to get not only for the security, other one would be the power. Right. Because when you want to get to 50 billion units, it's not going to be your massive devices. We are talking about tiny devices, almost sold for zero price, having the enterprise-less security and lasting for 10 years. So that's the engineering problem. Then you can bring in the cloud and application to control it, to either to increase the efficiency of whatever the device is doing, or probably add more services by providing some more analytics around it. But the first fundamental problem has to be solved to get to the 50 billion. Because the 50 billion is not going to come from your smartphone, not going to come from anything that we think that the cars or no. It is going to come from the so-called your consumer type of devices.
Yeah, that was my next question, because right behind connectivity is power. I mean, it's the power management issue and worrying about battery life and things like that. Are any of you exploring really interesting advances in power management?
Yeah. So actually, you bring up a very good point, and it kind of differs from application to application. And I'll give you some quick examples on this. Nest, I think, is a great product. They have a great thermostat, and now I think they have introduced a smoke detector as well. There are products where you expect them to run without any consumer, I would say, interaction for changing batteries and all of that for many years, at least a couple of years. Sensors are just one of them. So one of our customers, for example, First Alert is our customer, and most of their sensors and smoke detectors is powered by our technology. We spent a lot of time, research, and development effort in developing a very low power RF technology. And I think that basically helps in getting some of these devices where power is a critical concern, power management is a critical concern. You get it to a point where these devices or sensors can work for more than a year, 2 years with just 2 AA batteries or AAA batteries, right? So those things are going to be important. Even on Wi-Fi, and I'm sure Venkat can talk to this much better than I can, even on Wi-Fi, low power Wi-Fi, and BLE, like these are technologies where a lot of effort and investment is being put in to make it really, really low power, because power is going to be a concern in general.
Yeah.
Yeah, one more thing to add there. So this problem, in a way, I think you also have to look at it from an application development point of view, because a lot of time application, so if you take an iPhone, the iTunes actually, that's not even an application, because if they feel it's consuming a lot of battery. So a lot of times the application is written in a bad way, it consumes more power and bandwidth, right? So if, for example, one of the customers that we have, which is actually a water monitoring system, a water tank monitoring system. So these are huge water tanks way up there. You don't want to be going up there to change battery often. So what they do is the water levels are typically very small amount of data, typically talking about 1 or 2 kilobytes a day. So what they do is they actually send a device, sends an SMS. So if you look at a device from an SMS point of view versus IP session point of view, it actually consumes far less power to send an SMS. It doesn't have to wake up more components within the device to send an SMS versus having a full IP stack to send IP session. And also, in some ways, you have to look at the history of what happened. Like take, for example, the day Michael Jackson died. That's when many cellular companies realized how their video streaming system is not designed for video streaming system, right? So everybody is streaming their Michael Jackson video, and it really brought down a lot of cellular, network issues, right? So they learned from that, and then the Cisco's of the world, and all of them brought up a whole bunch of video optimization products around that. So the problem actually has to be solved in multiple layers. Some people call it as even fog computing, edge computing, where you are essentially pushing some of the computation to the edge, and that way minimize the data flowing up, right? So the problem is not going to be solved in one approach. It's going to be an application point of view, from a device point of view. So it has to be like a multi-layer solution.
Okay. So just one thing I'd like to add, that actually a very good point, that when we talk about mobile devices, obviously the battery is very important, the smaller is better. But all these things are still where humans are holding it. So a very intelligent person is around it. But when you talk about a device now you have gone to a device. Now we are talking about low power. So forget about somebody going and changing.
Right.
So that won't work too. So what we see is going forward, I think what Subbu said is correct. You have to optimize everywhere. But still, if you keep the paradigm of somebody has to go and change the battery, in my view, it won't work because it has to be energy harvested. So we are not dealing with human beings now. We are dealing with these 50 billion means there are a lot of things there. So we think that beyond this so-called optimizing at every level, we have to do it. It's very critical. You can have the greatest low-power chip. If you don't write the right application, keep it on all the time, nothing will happen. So everything will drain. So you have to optimize at every level, but the way you think about the low power, you have to think always you're not dealing with human beings. You are dealing with things which have to communicate like human beings. So that means you can't probably go reach to a projector there to go and change. So it has to be energy harvesting sources also would be some of the thinking. So in fact, in our company was founded based on the low power thread 12 years ago. So we are basically way into that one to do a energy harvested device. Next week we are announcing in Santa Clara. So those will be like
That's cool. That's very cool. How far away are we from wireless power transmission? I know there's a lot of interesting popular science articles about it, but is it anything that we could actually use for this in the next decade?
Decade, maybe. I would place my bet on it.
Yeah.
So looking at both kind of ends of the spectrum, enterprise and consumer, I hear mixed things where some folks are looking at enterprise saying this is where the biggest advances are going to happen in the near term in terms of IoT. Part of it because we've already accepted that we give up a lot of our privacy when we work for a company. We say, okay, we sign away essentially our privacy in the way we use the devices. The other is because of the money that can be invested in it, obviously. A company can spend a lot more than an average consumer. On the flip side, I hear people saying that no, it's going to be in the consumer space because people are actually really interested. They have a lot of connected devices. They want to see things coming together in a mesh. But where do you see kind of the biggest near-term opportunities for somebody that might be wanting to get into this space? Is it going to be happening in enterprise or is it going to be on the consumer side?
Again, I can take the near term. Obviously, we see the consumer place because it's easy to do some things. But in the really money making, if somebody wants to start a company and all that, that could be a different answer. But we see more things happening on the consumer side.
Interesting.
Yeah.
Okay.
So I think it's a difficult question to answer in a clear black and white way. But here's what my personal opinion is. In the consumer space, IoT will only take off and take off successfully if there are point solutions that are offered and the point solutions work very seamlessly. Otherwise, the IoT adoption will not happen. You're not going to get a success out of the consumer market by providing a very complex system. Let's say home automation, for example. Home automation is a word which has been misused and abused in different ways, right? You can have a multi-million-dollar home and you can sink in a couple of $1 million for very sophisticated home automation. Now the masses obviously won't be able to get it and they still would like to have things automated within the home. How will that happen? Well, we believe the only way that will happen is when some point solutions are made available, very low cost, and you get the traction from the consumer where they see the value of that connected device or the connected appliance end to end, right? They will go for one point solution, they like it, they go for another point solution, they like it, and all of a sudden you'll have at least 3 or 4 devices in your home, whether it is a connected refrigerator, connected thermostat, some of your wearables, if you will, right? All of this. And now all of a sudden, you get that traction in the consumer space. Of course, it will lead to other set of challenges, which I can tell you is going to be very interesting, because now on the phone you will have 10 different apps to control 10 different things. And that's going to be a pain, okay? So that's a different challenge, and I'm sure people will solve that. But once you get to that point, you will see the consumer space adopting IoT very, very quickly, and there'll be money to be made. On the enterprise side, there's going to be a lot of push on enterprise, primarily because as enterprises realize the value in having a solid connected device strategy, they will deploy, and we're already seeing this happen, a lot of R&D dollars and investment dollars in making it happen, because they see the benefit of, number one, getting a lot of ROI in terms of being able to service these products. Today, you walk into a Home Depot store, you buy a refrigerator, XYZ, you go to the store, you go to the cash counter, swipe your credit card, and Mr. XYZ is gone home with the refrigerator. Home Depot does not know who that consumer is. The appliance manufacturer does not know who that consumer is, because he may not register on site, right? But once you have a connected device in place, I think that process will happen automatically, and there will be a connection not only between the manufacturer and the consumer, but the retailer and the consumer. Now think about the possibilities. First off, the manufacturer has the ability to look at these deployed devices, and as Larry mentioned earlier, you now are getting telemetry data that says, okay, Raghu's refrigerator, by the way, needs an air filter replacement. I can be told, I don't have to wait until things go bad on my refrigerator, and I make a call to my, let's say, the service guy. The service guy, basically, company needs to do a truck roll, guy comes in, he checks and he says, oh, Mr. Raghu, your compressor is bad. And by the way, I need to order that part, and it will take me 10 days. And I'll have to come in again, by the way, to replace that, right? Now, if the device was connected, even before the truck roll was made, they would know that they may have to change the compressor. The guy may come in with a compressor, change it in that one truck roll. That's a huge saving on the enterprise side. So I think these are the things that you start adding up. Enterprises are realizing that they have to go and follow the connected device strategy. And so you will see a lot of money being spent and money being made as well, both in terms of savings, but also getting additional customers. And one of the reasons why you will see additional sales happening is when you get all of these devices from multiple manufacturers, multiple brands connected, and most of this connection will happen in the cloud. We strongly believe in that. It's not going to happen in the device. It's not going to happen in the mobile side or website. It's happening all in the cloud. Now, guess what? When you have all of those, that information from multiple brands, multiple manufacturers onto a common platform, you have a lot of opportunities to do cross-promotion. There will be new business engagement models that will emerge out of this. And we're already seeing that. We conduct a customer advisory board every quarter. We actually get all our customers under the same roof. And it's amazing with the kind of ideas they come up when they say, oh, now this is possible. This was not possible 5 years back, but now it's possible. We can do this.
That's interesting, because you look at these at a much smaller scale, but I mean, we all would be happy with the revenue that comes from it. But you look at the ecosystems that Microsoft's created. So an entire ecosystem that essentially spins around Microsoft and their products and people supporting those products. You look at the ecosystem that Apple's created, all the peripherals and the accessories that go with all the Apple products. Similarly, it sounds like what you're saying is this is going to happen on a much more, in many ways, a fragmented basis, because it's not going to be an LG ecosystem or a GE ecosystem or a Honeywell ecosystem. It's actually going to be kind of ad hoc players coming together. Is that what you're envisioning?
That's one thing. The other thing we believe is going to happen, and it will be kind of forced almost, is what we call internally as cloud-to-cloud compatibility. Everyone is going to be on the cloud. And the need to grow business and the need to play nice and expand this opportunity will force every business leader to think about how can I make my cloud compatible with XYZ's cloud? And you will see a lot of new engagements happening between clouds where cloud-to-cloud compatibility or cloud-to-cloud integration will start happening.
Do you see the same thing, Subbu?
Yeah, so to answer the other question about where I see the enterprise versus consumer, right? I mean, largely I see growth in both. In the enterprise side, let's take an example of a utility company, right? So in a utility company, some of the companies that we have connected devices are utility companies. That's basically a smart meter solution. So if you live in a remote location, you are a consumer who may be basically having a $200, $300 per month bill, best case. And it may cost them $50 to $100 just to somebody go up there to measure it. Right. So there it's a no-brainer for enterprise to invest money in a connected device. But the same utility company now in an urban area, the cost may not be as big of a gap, right. But still it's going to be $2, $3 per device, so you're still justified. But now you're connected, so what do you do with that? How do you invest beyond that? So that is where, if you take example like, you already see some example like PG&E where you can sign up for programs where you say that you're going to reduce your usage. For that you get a discount. But that's more like a trust and verify kind of an approach, not necessarily an enforcement approach where the smart meter can literally turn off the power. So for certain business, it's more easier than individuals because, you don't want to turn off power during an important game or something. So basically, that is where actually you can extend the, particularly it makes more sense because if you look at a typical how a utility supply chain management works, most of the utility companies that you deal with are not making the power. There is a separate generation company, and they actually are ordering from a coal or gas pipeline. And so they actually have a tier, right? So a utility company buys a bucket of electrons and distributes to us. And then they go over the bucket, they get a higher rate. They have to pay the generator, right? And the generator actually has a bucket that they are actually buying against the coal and manufacturer. So if they go over the bucket, they have to pay at a higher rate for the coal. So there is, and at the end of the day, you really cannot manage the peaks. You can only manage the peaks, but really cannot manage the actual average.
Right.
So by actually timing, making sure the peaks are not overlapping each other, you can actually use smart meters where right now smart meters are used what I call as read-only mode, where most of the time it actually collect data to minimize the meter reading cost.
Right.
But if you extend that into read-write mode, where it's able to enforce the power management and actually have cost saving around that for the consumer and for the enterprise, right? So these are some of the examples that can come along later that would actually encourage enterprise more. Even in the connected car, for example, consumer sees the benefit. I gave a few examples of that. But if you take the enterprise side, there are many big car companies, they lost their reputation in the last 4 or 5 years by having major problems like accelerator taking off by itself and things like that. So imagine that you're able to collect the car, the information from the car. You are able to actually proactively do recalls. So it's silent operation happening in the back. And yet it may even happen without actually having the company's name, being affected.
Right. So you kind of raise an interesting question that I have. I think we all understand we're kind of comfortable with machine-to-machine communication and saying, oh, passing data and being able to share that and aggregate it and do things with it. I think there's a big difference between M2M and actually going to that next level, which you were starting to talk about, which is policy enforcement. So setting a policy, even as a consumer or as an enterprise or a company, saying, if this happens and this is communicated, automatically apply this policy, automatically throttle back my energy usage, automatically change something in my car because of gas prices or whatever it might be. How comfortable are people going to be with auto policy enforcement versus being informed and the human being still essentially pushing the button?
Yeah, I basically, again, it's similar to privacy issue. It's not going to be an easy answer to give. But what I can give, there's another problem there too, because you need to have a technology that can actually do it and scale at a level.
Right.
Right now we are also focusing on how we can develop a technology that can do near real-time processing, so it can scale at a level of thousands and thousands of transactions per second. But really speaking, to answer your question, actually, I really don't know the answer to that because it's really similar to privacy. It really depends.
Because I've heard they're experimenting with this in Europe, for example, that they have speed limits, and then they have sensors and detection, and then when an automobile approaches and the speed limit is now 20 kilometers an hour, the car automatically slows down. I mean, you have no control over that as the driver. You can't go faster than the speed limit. So that's a huge change. And how comfortable are people going to be with that? Any other thoughts, or have you, touched on this?
Yeah, it could be the segment based. In some cases, it is okay to do it. For example, if something is happening bad, you have to shut it off. There's no legal or anything, common sense thing. So it could be a segment based policy enforcement, but it won't be like if I'm going very fast, automatically my car comes to zero. I think that would be pretty serious. But
it's actually the DUI example, right? So that is something it's going to work, right? Because pretty much you are already in the system. You're already giving up your right in a way. So.
Yeah, that's a good point.
Yeah. I think it will be on a case-by-case basis. I don't know how many of you read. I think it was a news item yesterday or day before. So Apple got granted a patent for geofencing, which again, I don't know how someone can grant a patent to Apple for geofencing when people have been doing this for many years. But anyway, now it will be possible for the movie theaters to actually shut off your phone when you enter a theater.
Right.
What do you do with it? So I think some of these use case scenarios are scary and of course very concerning. But my personal opinion is in some cases I think it'll be good. Depending on how the use case is applied, it'll be good. But in some cases we'll always be concerned and there'll be a little bit of thrashing.
And also we all, take for example, right, the Amber Alert. I think many people here got the Amber Alert at 1 in the morning at almost midnight.
Yeah.
A few months back, a few weeks back.
Yeah.
So we already have this problem, but people actually have tolerance for those kind of things because what is at stake behind that, right?
Right. So I'd like to ask each of you to think kind of creatively about what you personally, now that you're quite familiar with this space, and you know a little more than the average consumer, but think about what would be the opportunity that you would like most to come real, whether it's in your enterprise life or it's as a consumer yourself. What are you really looking forward to that you think will be enabled by IoT as a personal user?
So let me give you my personal opinion on this. Internet of Things has been around for many, many years. I would even say decades. It's all being done in different ways. I think what has happened in the last 5 or 6 years is there was an inflection point with the smartphone, right? Once the smartphones got introduced, iPhone got introduced, all of a sudden, our world has changed. The paradigms have changed. Everything has been turned upside down. And what's happening now is every single device out there that was collecting telemetry data and sending telemetry data using some communication protocol for more than 20 years, all of a sudden it's become important, both for enterprises as well as for consumers. And what we are doing right now is just rehashing the same thing again, but making it more contextual, more useful, more beneficial. You're now looking at the data, you're trying to figure out how to mine the data and make some sense out of it. So in terms of where I see this going and how I believe the value is going to show up for as an individual, as a consumer, is it's all going to come down to personalization for an end consumer. I think you can talk about enterprises separately, you can talk about consumers separately, but if you're really talking about just consumers, what they are going to look for is how are all of these things that we call as Internet of Things helping me or helping my lifestyle? Mm-hmm. Is it making things simpler or more difficult or more complicated? And that's where either IoT will take off or miserably fail. And there are going to be so many players, and you can already see this right now. There's so much noise around about IoT. There's so many companies, there's so many players in this space, and it's just not sustainable. I think over a course of next 4 or 5 years, I see consolidation happening. The stronger players will emerge. And when I say stronger players, these are players who deliver real value, who provide seamless, intuitive experience, user experience to consumers where common user or the masses don't have to go through technical steps that most of us actually know. You have to remove all of those barriers. And I can tell you the biggest barrier right now is for Internet of Things is provisioning and onboarding. Like you get a connected product, you have to go through 10 different steps before you can even make it functional. That's not going to fly. You can never make the technology a technology for masses. It has to be so simple that you plug it in, connect the power, it should work, right? And if it works, then you will see a lot of adoption happening. And at that point in time, I see personally the personalization aspect being very important because guess what? All of you carry a phone today. That phone is personal to you. There's a lot of information that's very personalized for you. And you don't leave the phone. You take it along with you wherever you go. And that's going to become almost like a beacon for you. You enter your home, you enter a room, that phone is going to tell the surroundings what it has to do. And I think that's where you can see some very interesting things happening.
How about you, Venkat?
So the way I look at it is when a connected device is connected, device has its own functionality. Like Raghu mentioned that these things were existing devices. We're not even talking about the new ones. Once you connect to the internet, first thing it does is it enhances the functionality of the device. If you have a thermostat, it is enhancing its functionality. Thermostats were there in the business for years, we have been using. You take an example of a vending machine. The moment you connect to the network, the business efficiency goes up, and the functionality of the device goes up, user experience goes up. Let's look at that scenario, how it happens. Because you connected to the network, the business operator knows when to replenish the stuff when it's getting over, so his efficiency is going up. And the consumer side, when I want to take a particular Coke, that particular location that is available now. Earlier it was not there. So my user experience also goes up. So device functionality goes up, business gets money, consumer feels happy. So the way I look at it is if you successfully deploy the right cost, right technology, the business has to get money. And on top of whatever the business efficiency, like what we talked about, analytics part of it. First thing is you make more money on the existing, try to make more money on the still existing. So that is also possible for the business. And from the consumer point of view, your user experience has to enhance, whether you put it in the refrigerator or the thermostat or whatever the device, it becomes an IoT device, consumer has to get benefit out of it. Only then it is sustainable to pay some money and deploy it.
Okay. Subbu?
So as an individual, right, most of the time, you're looking for these devices to be connected either for convenience or cost saving, one of the two major motivators, right? So today, when I hopped onto my car to get over here, I basically turned the Google map. I was surprised to see in the search button automatically it popped up town hall address. So it mined my email and it realized that I'm going to be actually most probably looking for it. Some people it's convenient for me because I just clicked on it, done, right? But at the same time, there is a data integration problem in Google, right? So what happened is, tomorrow I'm actually leaving to India for a trip. And I actually earlier planned to go on Friday, and I actually postponed for this event. And actually, it had my older emails. So it's been giving my status in the Google tab, on the applet, actually saying that my flight already landed. So, it doesn't, reason is because the United is not integrated Gmail, right? So you're going to have more problems like that because each sensor is going to know its own context. And the context actually gets back to the backend server, and each backend server in their own silos. But if you don't have a standardized way of people able to share that in a secure, stable way, as a consumer, I'm not going to get the value, or I'm going to have this weird, Gmail problem where it's telling me my plane landed already.
Right. Good point. So I want to ask one last kicker question, which is, it's come up. People, when they were talking with folks about the Internet of Things, and talking about wearables. So I don't know if you're familiar with the Misfit Shine. Have people seen this? So it's a very, very small. It's meant to be a fitness and health tracker. It's about the size of a quarter, and it's about that thin. And got a chance to meet with those folks recently. The kind of logical evolution of some of this is actually going from wearables to embeddeds. And you would think people wouldn't do this, but if you're familiar with Tim Ferriss he's kind of a quantified self guru and geek. He actually embedded a glucose monitor in his own body. He doesn't have diabetes, but he just wanted to track his glucose levels. So he embedded it. How far away are we from this actually happening and people becoming comfortable with shifting from wearables to actually embeddeds. And this is a change that's connected humans. Right?
Dick Cheney, right?
It's a huge change.
Dick Cheney.
Yeah. I mean, we have heart monitors, we have insulin pumps.
Yeah.
But to your point, if there's value, you know, if your wallet is now in your wrist instead of your phone, so you never lose your wallet, what is that like?
So I think, I do not know much, but I did come across some customer who was trying to do something like that, embedding a wireless inside his body.
Yeah.
So my common sense thinking was that, hey, you can't do it, you need to get FDA certification, a lot of other procedures. But it appears it's not true, because if you don't have to keep it for a longer time, you can do a lot of things without, it seems, that you don't have to wait a lot of those certifications. If that is true, then it will happen.
Yeah.
So if you assume that everything you have to do, that to get 4 years of certification, that is a different story. But if you can do every 2 weeks, you will replace it or do something. Right. You don't need to get any certification, I believe. That's what I learned.
Wow.
If that story is true, I think it's very much possible.
I think that's a great question, and it really forces us to think what might happen in the future. I personally feel that it really depends on the generations, if you will, because I think things that we thought, or for that matter, my parents thought are going to be taboo are no longer taboo now, right? And things that I think are taboo now, I'm pretty sure the coming generations will think they're not taboo anymore. So it's just how humans evolve and how generations evolve. It may be foreign to us right now to even think about embedding something in our body unless it is so critical. Like Dick Cheney is a great example, and I think there are some insulin pumps that you actually embed. But who knows? I never thought that, okay, the wearables, like even 3 years, 4 years back, I never thought this would be like such a big industry. And it's just growing. And there are people just adopting it, taking it in. Same thing I can talk about social networking. I'm not a big social networking fan, but I look around me, I'm like, I'm the only odd man out, right? So what do you do? Yeah. So I think it's just evolution, and it's just generational, in my opinion.
I think it's a good point.
And in some of the IoT meetups that we had some of the manufacturers of hardware who basically makes a complete embedded Linux running a web server in the size of probably a long-grain rice. So these are all prototypes. Wow. So the goal for them is actually to embed them in the example use case he had was these are all prototypes and not expensive. Each rice is probably $200. So each grain of rice. So they want to embed that in LAMP and things like that. So I don't see how it is impossible. I think there's going to be. I would think that some way the adoption on that may be more in Asian countries where the regulations are easy to either they don't exist or easy to get around, versus countries like Europe and US. I think those things will be lagging a bit. Okay. Because again, if you look at the M2M space, the pioneers are actually here and Europe. Right. But if you're talking about people who are actually in development and thinking about it, actually there are more people in Asian countries than here.
Good point. And with that, I'm going to open it up to questions from the audience. We have a few minutes left.
Hi, my name is Ashish. So I just want to reiterate a few points that were made. So Raghu sir said that it's IoT has been a complex problem, and there have been failures in the past. And Venkat sir said that it has been a scalability issue as well. So my question is, as we were talking about that these millions of devices would be the device itself. And what I see is, my first question, like being ability to communicate wirelessly, a huge bandwidth. So is this a basic science issue, or can it be an engineering issue? Like we work on it in the industry, or do we have to wait for the basic sciences to work as well? Also, the same goes with batteries. Like, should we work on them and also wait for the sciences to be in tune with us? So that I'm asking this because, say, I'm an entrepreneur trying to go for that million device-based industry. How should I time myself? Like, where?
Right. Well, great question. So first off, I think when I said there have been enterprises who have tried this in the past and they have failed, and Venkat's point about scalability, which are like absolutely true, right? I'll tell you the reasons why some of these companies have failed. Most of these enterprises, they have an IT department, right? And that's the department that will be entrusted in trying to roll out this strategy, if you will. And the way they think and the way they approach this problem is slightly different because that's what they've been doing all these years, right? So you try to, and I'm going to get a little technical over here, they're going to try to build a device. First off, it's not a thing anymore, it's a computer. So they will build a computer, right? And then it'll establish TCP, SSL-based socket connections. Now, your whole cost of operation for that, in terms of deploying those massive services on servers on the back end, is going to be humongous, right? Doesn't work. So you need to start approaching to try to solve this problem from a completely different perspective. You have to think, first off, these things have to be things. They cannot be computers. It has to be so lightweight that all they're doing is sending telemetry data. Now, of course, there may be some applications where you may be uploading video and big files and all of that, but they're slightly different. But for most part, the sensors and all of that, they are all sending like data which is in the telemetry range, right? But still, they need to be connected to the cloud and upload this data on a periodic basis, and then cloud does processing of this data. And you need to have an infrastructure that's really, really serving you in terms of low cost, right? And you need to have technologies for that. Now, in terms of the scalability, that's how you start building that infrastructure. So you can now onboard not hundreds, not thousands, not 10,000s, but now you can onboard millions and millions of devices. And you're now talking about a seamless infinite cloud that you can now add more boxes and you can horizontally scale, right? There is a complementary aspect of it, which is obviously the data sciences, because once you start looking at this data, believe me, it's overwhelming. Like we have guys in our team who are looking at this data and they are like, oh my God, this is so much of data. And I can tell you, sensors with time series data, you'll go crazy, right? So you have to have techniques that say, how am I going to sieve and filter out this data? And you will see as these areas develop more and more, you will find expertise being developed in data sciences. I think Subbu talked about that a little bit. You will see experts getting more and more competent in trying to identify how to get the data that really matters and how to use it for not only predictive fault analysis or predictive CRM. Predictive CRM is another big thing that's going to happen, right? And I'm sure some of you must be following that. But predictive CRM for enterprises is a huge opportunity because you can actually look at data that's coming in right now and try to start doing some modeling for what kind of CRM you can do in the future.
Go ahead, please.
Yes, hi. My name is Harsha Srivastava. I'm an IoT enthusiast. But my question is motivated by thinking on a bigger scale. There's a well-known company which is talking about at a city and a planet level thing with Internet of Things. So my question is, where do you see that going on a bigger scale, like a city or a planet? What are the trends? What are the opportunities, issues, and concerns? And how do you think our lives will be transformed? Like, am I able to find the perfect parking spot? I mean, I know when my next train is coming, my next bus is coming. How do you see the transformation happening? One of the speakers said that we're going to see a transformation in life in the next 5-6 years. So, wanted to get some, insight into that.
Yeah, I was just at a conference, recently where we were talking about this huge transformation that's happening with the kind of the intersection of connected devices, big data in the cloud, and then being able to essentially take what was offline, became online, and now is moving offline again. And so to your point, being able to say, why can't I find an open parking space? Looking at things like Uber as a service saying, bring the cab to me. Why do I have to go find a cab? So I think that is the transformation that is coming, is actually taking all the data that we can collect from the offline world, bringing it online, doing something meaningful with it and transforming it, looking at trends and patterns, and be able to offer that back to a consumer as a service saying, here's how you can now finish that transaction in the real physical world and do something you couldn't do before because we weren't aware of any of that. And so it is going to be possible. I mean, the things you're talking about, like the train's coming, the bus is going to be late, absolutely. I mean, there's no reason some of that couldn't be happening today. The only problem is no one is actually building the application layer on top of that right now. And so for somebody to actually take that data, which is available, and say that is meaningful data that could be offered as a service to somebody and be able to create an opportunity, I think, for somebody who wants to play in that space, absolutely.
I actually know of a company that I don't want to name here, but they are focused on going after municipalities and trying to deploy this kind of technology. And it's amazing how they're looking and trying to solve the problem. Like they will go and specifically take care of all of the street lighting, like that's all controlled, right? Parking meters, a whole bunch of these things. But you will see this happening more on a pilot basis to begin with. I think they're going to run multiple pilots, learn from what they're doing and what works, what doesn't work. But I agree with what Larry says. I think over a period of time, I think this is going to happen.
So I think just to add to that, what kind of trends do we see, and whether it's going to be mass scale deployments? One of the metrics is that if it's going to be increasing the operational efficiency of the company which is deploying, that's one aspect. But if it doesn't have the user experience, enhancing the user experience, then it will be slower. So wherever you see some segments where all these metrics are meeting, you will see that happening a lot faster.
Yeah, one more thing I would add is basically the concept of crowdsourcing becomes more relevant with IoT, right? Take a real world example. Again, the automobile space is more real world example for us because actually that's one of the pioneers. So we actually have a lot of use cases around that. So if you, again, traction information from the tires available. So there are ways, there are algorithms where you can actually predict if there's a black ice in the road. So imagine one car is able to sense the black ice. The other cars actually can get sensor, and then you have a screen, in your screen actually you can alert saying that, hey, you have a black ice possibly a couple of 100 feet from you, right? So that one car may be affected, it may slid off the road, but at least it's not affecting the other cars. So that's an example of automated crowdsourcing kind of trends we are seeing, right? But again, like you mentioned, most of them are more like pilot projects, and a lot of time the problem happened to be, regulations around sharing data, and also data silos, because a lot of time the value of one sensor is not going to be enhanced as a higher value by correlating it with some of the data sensor.
I
have a question.
I'm sorry.
In which area the IoT most activity is happening? I mean, it's like, is it defense, agriculture? Where do you see most likely, if we want to develop something, what areas you can suggest?
I think automobile is actually reaching a point where I think it's going to be very stable. My guess would be where, if you imagine how the GPS used to be, where 15, 12 years back, it used to be in high-end cars, embedded GPS, right, or the GPS screen in the car. So now we have $15,000 car has GPS out of the box, out of the lot. So I have basically the connected car. I see that to be the case 5, 6 years from now, where the connection, it becomes almost standard, feature of a car. And if you take the other areas, actually, the utility area is again another area where I think it's going to really take off and start adding value to end user. And the rest of the connected area is a lot of them are pilots in what we are seeing. And the other third area I would say is medical area, medical devices area.
Hello, my name's Ava. So could you explain more on the dark side of so much connectivity?
Dark side?
What's it?
What side?
Dark side.
Can you repeat your question, please?
Can you expand more on like the bad side, the dark side of so much connectivity? What bad effects it could have?
The dark side, I mean,
Okay.
it's like
I think,
privacy concerns.
Okay.
Yeah.
So I think, the other gentleman question I think is very important point when he said, is there any, because I said a lot of challenges, we say 100x different paradigm and all that. From the science point of view or the connectivity point of view, what happens is, because we are working in this low power wireless for the mobile phone for 12 years. So one good thing about is, as far as the science and technology is concerned, mobile phone is a superset. Smartphone is a superset. That means per se, you don't have to worry there is a energy harvesting, low power technology, wireless technology. We have to invent to provide a solution for IoT. That is not going to be the case. So that means already once you have the way we are progressing on the so-called the a pleasure purpose for the smartphone design, the technology that goes in, everything else would be subset as far as the connectivity is concerned. So that means you don't have to worry. It's a question of figuring out the equation in terms of meeting those user experience, somebody making more money in the operational efficiency. All those equations have to fit in. But of course, in the like Raghu and Subbu mentioned, in other areas, maybe there is a lot more research can happen in terms of digging a small piece of data from a bigger database that you have. But when you go down towards the device, the superset is the smartphone.
So I have a question on dark side of connectivity. So especially when embedded devices can be hacked into, like what you saw in the Homeland series, wherein the pacemaker of the general is shut off by somebody hacking into the manufacturer of the pacemaker. And I know that it can happen in real life where a disgruntled employee in Australia who was working in a sewage company turned on sewage to spill out in a park somewhere when he was fired. So what sort of security implications does it have, especially when it is not read-only access, but read-write access, when somebody can really manipulate the system? So what sort of regulations are you guys
So I think,
going through?
one thing, as I mentioned, right, the current thinking of so-called the low cost, that has to be, still, of course, everybody likes the low cost, but you cannot have these low-cost wireless technologies. So today, for example, you take wireless LAN, it's a replacement for Ethernet. That's why we call it Wi-Fi is wireless LAN. Other wireless technologies we don't call like that because those are not designed for networking purposes. So once you implement the right technology, wireless technology, it comes with the all IP proven security already. Only the question comes is, can you offer it at the price point that we are asking for? So in every point of view in terms of the security controlling is a zero issue. It's just that the right technology is not deployed because we are falling for the $3, $2 stuff. Otherwise, today you go to your office, you are wireless, you are connecting to the most advanced company's network without any worries. That means technology does exist today. It's just that we want to bring in that technology at $2 price point. That's a real engineering challenge.
So I would just add, and this is very specific to the security topic that you brought up, I doubt that there will be some sort of standardization effort coming in anytime soon. I think this really becomes the responsibility of the manufacturer who's going to put their brand name on the product that they're going to sell. And they are going to be under increased pressure to make sure that their devices are secure. Now, first off, there's enough, I would say, components of technology available over there to at least provide basic security. The things that you've heard out over there, most of the times, either the products were really designed bad, they never went through any sort of internal security audit also, and I think that's going to become more and more important. The good news is, unlike these open platforms like PCs and Macs and all of that, most of these things, if you will, run on platforms where, unless it is an embedded Linux, they run on really microcontrollers with some real-time proprietary kernels. Very difficult to kind of go and hack those things. Of course, you can still come in and hack from the cloud side or from the mobile side, but those things can be secured, right? So that's number one. The second thing which I believe is going to become more and more important is, I think we internally discussed this as role-based access, right? Like you create an account for yourself once you bought a particular connected device. You need to have multiple access privileges. Like you must have probably full access, but if you want to share that with someone else, then what kind of access privileges can you provide, right? Also, for the manufacturer should never have full access privileges, but their support guys should probably have some privileges, which, by the way, you can increase or decrease based on your discretion. So if you are calling and talking to a support agent and you say, I want you to debug my garage door opener, and I'm going to temporarily give you some access privileges, right? So those things are all going to come together, and that's the only way to secure the product.
So my question is related to the standardization you talked about. Again, it's a great panel, great discussion. So is there any work being done towards standardization in IoT?
Yeah, I think, again, automobile space is one area where actually, as more like CAN bus, for example, the connected area network bus, basically, there are a lot of protocol area where there has been standardization. Okay. But the standardization from a back-end point of view, like how do you actually share the data from sensors? in a reliable, secure way. So those kind of standardization has not been happening, but it's been happening more on the connectivity part. There are a lot of evolving standards out there.
Thank you.
Thanks so much for taking my question. My name is Prasad. Great insights and great panel. I have a question related to sharing economy, crowdsourcing sharing economy. So we all know that we are using social networks not to just share advice or photos or media or things like that. I mean, we are sharing to sell our space or excess inventory or do transactions with other people. So my question is, what do you think the trend will be, especially in the Asian countries, related to sharing economy? I mean, do Asian countries really want early adopters in the Silicon Valley, as it happened with Facebook and other things like that? Because what we see right now, the trend is everything starts in the Silicon Valley, like Uber or Lyft or Airbnb. They all start in the Silicon Valley. Then it spreads to other parts of the world. So what do you think will be the trend, coming trend? And what is the regulation? What is the government regulation related to it?
So you're talking about, I don't know if I got your question right, but let me give an example, right? So I think it's some village in India, one of the, so normal thing parents do to a kid is, can you go and turn off the light in the upstairs, right? So they don't want to go up there and do it themselves. So he actually, his father always goes and asks him to turn off the motor or turn on the motor that pumps their field, right? It's a water pump that actually irrigates the field. So he actually came up with the hardware that actually SMS sent to the motor. So he actually can just send an SMS to that. So he gave that to his father. From there on, he's free, right? So, and then I'm giving more example in the Indian countries. One of the RFP that we had was to developing countries. Most of the cellular towers are actually operated off the generators, diesel generators typically, right? They actually have a common problem is people are coming and stealing the diesel. So what they want to do is they actually want to have a sensor in the tank. So if you look at a sensor tank, the fuel level, there is a natural slope to it because the fuel is being consumed. But you can actually have a near real-time monitoring of that, and the slope is changing at a certain rate. Then they want to stream the video to see at least they know who is stealing it. They can't block the stealing, so at least they can go after them. So I think in the M2M space, the problem set is going to be very different depending on the cultures and the country, and the problem set are going to be different. The innovation, a lot of RFP we are seeing from operators in India is very different from some of the RFPs we are seeing here. That's and we are seeing a lot of innovation around that in countries outside US.
Thank you. This is Narajan. I would like to ask each one of the panelists maybe to give their opinion about the top 3 device or application segment where they see the highest volume of M2M connectivity or Internet of Things connectivity.
Go ahead.
Top 3? Well, I think I would agree with Subbu that you will see a lot of connectivity and connectivity applications come up in the automobile industry first. I think they've gotten clearly a head start. Some of the devices that you have in your home, in your living room, you may not know it, but they already are connected, like your connected TV. We call them smart TVs. Unfortunately, no one has really figured out the killer app. So we all talk about Netflix and Hulu and all of that, but I think they are going to play an important role in the living room. The other thing that I do believe is going to be important from a consumer perspective is you are going to see in the next, I don't know, couple of years or so, a lot of these point devices that I keep talking about. Lighting is a very good example. You will see connected bulbs appearing all over the place, and you'll have apps that can control these lamps, and you can come up with some detailed orchestration of, okay, what needs to happen when you enter your home, right? What lamps should turn off, what lamps should turn on. I think I see that those things are going to happen.
So I think my side, I always say that it's an inch deep, mile wide. We try to figure out which market segment is going better. We see for 9 months, we sell something into the healthcare, then suddenly it becomes home automation side. So we could not figure out anything like that. It's basically across all. But if you ask me, fitness, one thing is something that we see could be happening, whether it could be health related at home or individual, but that's one thing on top of whatever Raghu mentioned. As far as the automotive thing is concerned, I think it's a little bit more mature, but there is a little bit of a challenge for entrepreneurs because that markets are something like generally if you try to put anything in the car, there's a different level of challenge in terms of the cycles and all that. Yeah. So it is definitely more mature, but I would not just think that there's money there. I just want to give you because I've already gone through that one quite far. So it's more mature, but almost you have to consider this. Don't even think of that one to make money. Although software side is still is maybe there be, but I consider consumer fitness with something that there is an opportunity. And also in terms of the easy to deploy, because we know that is inch deep, mile wide. And if anything can be done, a framework that level, that would also be something interesting. That means a number of applications people can think about, there will be too many, but what framework can have. Of course, the cloud is trying to solve in a different way too. But is there something still cheaper way? Because everything it boils down to cost here. Whether you do it at the device level, whether you offer a SaaS model, whatever model you offer, unless you meet the requirements of the consumer, the guy who produces, guy who services, all of them are feeling happy for the IoT, is not going to fly because the cost equation won't work.
So again, I think from my top three, it's difficult to do and that lasts for a longer time, right? If you take an example, in the last few months and probably for the next couple of years, the shale oil drilling in the northern part of US, a lot of our customers actually are, the oil and natural gas sector has a lot of growth in that area. So they want to monitor the oil pressure and, again, the cost saving point of view, instead of actually somebody driving around the truck to monitor each and every well, they're able to actually have a central location where they monitor it and they still have somebody go out there, but that's in reaction to the numbers they get, right? So that's a hot area right now in certain parts of US. But you go to some other part of, in Australia, for example, who knows, right? They have so much fire problem. Maybe you want to have sensors to catch the fire early enough, right? Mm-hmm. So it really depends on the context, and it's going to keep changing. Because the beauty of this is really trying to solve someone's problem. And what problem is keep changing, every 5 years, 4 years, always going to have some newer problem. Take an example, when we had the tsunami, right? So one of the IoT example that somebody had a beautiful example there, where people actually had radioactive sensors. And people are able to predict, these are all individual amateur radioactive sensors people had in their home. And they actually are able to share the data. And based on that, people are able to predict the radioactive flow. And that even helped both enterprise and individual users to avoid areas where they want to be. Some of the airline companies use that data to actually even predict their flight path. Mm-hmm. So that is the beauty of the data, and really difficult to say what is going to be hard because you really have to, there's so much creativity there and so much room there. So.
Actually, it is a good thing for entrepreneurs because you don't have those three top. Because if you take the smartphone, it's very nice volume, but it's almost like probability of doing anything is very less. Whereas here you have inch deep, mile wide, a lot of creative things can come up. So it's a very, very lucrative thing. That good that you don't have that.
Hi, I'm Dhaval, and what about the software standardization bodies? I mean, which are the common, like there's IETF for networking protocols and all. Can you just quickly mention some of the places?
Unfortunately, there's no single software standardization body for IoT, but you will find some fragmented efforts happening right now. Like for example, there's a standards body that is focusing mainly on communication between the device and the cloud. Again, just like any other standardization effort, there's a group of companies in one camp, there's another group of companies in another camp, and you know the story how it goes. So the standards efforts are really fragmented. And I also believe it's going to be very difficult, and I would prefer not to have a standards committee that standardizes everything end to end. I think you'll probably see some standards coming for each of these components of IoT, which I think is good because then you get a choice of trying to choose the best technology and stitch them together. But if you're trying to look for one single software standardization body, first off, I don't think it will happen. I also believe if there's some effort being put in, I think that's wrong. I don't think it should be the way to go.
Thank you all for your questions and appreciate your efforts here.
Thank you.
Thank you, guys.